So now that you're familiar with dienes, familiar with electrophilic addition reactions in general, and the possibility of both kinetic and thermodynamic control, let's put it all together and look at a couple practice problems. So the first problem that we'll look at here, we're going to have our diene. Get out of highlighter mode here. And again, the rest of the structure isn't overly important. It kind of just comes along for the ride. Although it does matter initially when you're trying to figure out which carbocation you're going to form and so on. But don't let the rest of the molecule overwhelm you too much. We're going to react this with one equivalent of HCl. And we're going to do it at 0 degrees Celsius. So remember from the kinetic thermodynamic control video that when you cool your reaction down, it's going to go through the easiest pathway, which is the kinetic product. So we're under kinetic control here. And we said kinetic control is going to favor the 1,2 product. So first we need to decide which carbocation we're going to initially form. So if I look at the upper double bond, my 2 carbons, and remember Markovnikov's rule, I'm going to add the hydrogen to the upper carbon because it already had 1 hydrogen, which puts my carbocation on a tertiary carbon. So that's one option. The other option, if I look at the other double bonds, I have the not that one. I have 1 on the left, 1 on the right. And again, following Markovnikov's rule, the hydrogen is going to add to the carbon with the most hydrogens, which would be the one on the end because there's already 1 there. So I will form this carbocation. So the blue carbocation is a tertiary carbocation because there are 3 other carbons attached to it. The green one is, well, I just wrote 2, sorry. Tertiary, which is a 3. The green one is secondary. It only has 2 carbons attached to it. And we said tertiary carbocations are more stable than secondary. So the one that's going to form is this first blue structure. The green one is less likely to form. So unless you're asked to draw all possible products, you're going to focus in on this first step, deciding which carbocation is more stable, and then follow that pathway. So I can add the bromine to the initial carbocation for the 1,2 product. I could do resonance and get to the 1,4, but remember we're under kinetic control. So this right here is going to be the major product formed for this reaction under kinetic control. Again, you have to decide which carbocation is formed initially. And then based on the conditions, you'll decide, do you end with 1,2 or do you have to do resonance and get to the 1,4 product? So let's look at what the 1,4 thermodynamic control option would be. So again, let's do one equivalent of HCl. Now we're going to heat up to 40 degrees Celsius. So the first step is going to be the same. We're still going to form that more stable tertiary carbocation. But now we know we have enough energy to eventually get up and over that higher barrier. So we are going to form the more stable double bonds through resonance here, which puts the positive charge out here on the end. Now that is a primary carbocation and is not very stable, but again, if we heat this for long enough and let the equilibrium go for long enough, it will eventually trickle down to that more stable final product. So the bromine now is going to, we're adding chlorine. Wow, sorry, all kinds of mixed up here. We should be adding chlorine, not bromine. Nothing else changes. It's all the same otherwise. So the chlorine will now add to that end carbon. And the double bond has moved a bit. So now we have our 1,4 product because we were heating and under thermodynamic control. Let's look at another example. So we're going to look at this diene. And this time we're going to react with Br2. So everything we've really looked at so far with these additions have been HX. You can always also use X2, so Br2, Cl2, either one will work. And it's going to go through the same process, except now instead of adding H and Cl or H and Br, you're just going to add 2 of the halogens. But otherwise, the thought process is more or less the same. So again, we need to decide which carbocation is going to be formed initially. So we've got a few options. If we look at the left-hand double bond, we have the carbon on the end, or the second carbon in, and we know we're going to form the more stable carbocation, which means the first bromine is going to add to the end so that the carbocation that is formed is a secondary carbocation. The other option, if I look at the other double bond, is if I put the bromine on the ends, the carbocation will form here as a tertiary carbocation. So this tertiary is going to be better than the secondary. So the secondary is out, and we're going to follow this tertiary pathway. So if we go through the fastest forming product, so what's going to form just from this initial carbocation, the second bromine will add to where the carbocation is for our 1,2 product. If we do some resonance electron shifting here, we will form another carbocation, which in this case is primary, less stable, but under thermodynamic control we can get there. And now we're going to have our 1,4 product. So those are going to be your 2 options. And if we think about which is going to be favored, again, 1,2 is going to be favored under kinetic control. The 1,4 favored under thermal control. So that thermodynamic, we're going to need to heat it. Kinetic, we're going to cool it to get one preferred over the other. Now you will get some mixture, even if you're under control, one of the controls or the other. But if you're asked to give the major product, focus in on 1,2 for kinetic, 1,4 for thermodynamic.